Hello, welcome to another episode of Naked Neuroscience, the podcast exploring the workings of the brain and the nervous system in our bodies and beyond. I'm Katie Haler, and this month...
Imagine lying in your bed, sleeping, but then realizing that you're actually awake, but you can't move or you can't speak. Suddenly you feel like, oh, there might be some ghostly presence in the room, so quite frightening.
From internal vision to things that appear to go bump in the night, we're talking about hallucinations. Plus, as usual, we're joined by our local experts to digest some of the latest neuroscience news. To the news, and this month, Anglia Ruskin University perceptual psychologist Helen Keyes looked at a paper studying the implications of adults wearing face masks on children's abilities to interpret emotions. Helen explained that our brains are excellent at processing faces, and that they prefer to see faces as a whole.
It does much better when it sees eyes, nose, mouth together. You're much quicker and better at interpreting facial emotion and identity. Children's ability to infer emotions from facial expressions is strongly linked to their, later development of social competence. So that there is that link. There would be a small worry there if children weren't getting that exposure or that practice at inferring facial emotion.
So the question is, how much of a challenge does a face mask present to children's brain's perception of someone else's emotional state?
This study focused on 81 children who were between the ages of 7 and 13, and that's a real key age where children start to rely heavily on using eyes to interpret emotional expression. Now, these children saw lots of images of faces, and the faces had different facial expressions, sadness, anger, and fear. And the images would start off really fuzzy, and they would get clearer and clearer, and the children would say which emotion was being expressed in the face. Obviously, as the face became clearer, this task became easier. And the faces were either presented as a whole or presented with a face covering over them, just a surgical face mask, or they were presented as wearing sunglasses. And as was expected, children were the most accurate at identifying facial emotion when there was no face covering at all. So no face mask and no sunglasses. That's not surprising. However, that effect was relatively small. Indeed, when we look at the individual emotions, children still performed significantly greater than chance at recognizing the emotion for sad faces. Even if the face is wearing a mask or wearing sunglasses, children still performed better than chance. They could still tell that the face was sad. When we look at angry faces, again, wearing the face mask didn't have that much of an effect in terms of children still performed better than chance at recognizing the angry emotion, whereas sunglasses really impaired that. And then it's only really when a face was expressing fear that the introduction of any sort of face covering, so a face mask or sunglasses, really made it hard for children to interpret that emotion. They found it very, very difficult to tell if the face was expressing fear or surprise when you have that almost wide-eyed look, if they're wearing either a face mask or sunglasses. So there is quite a lot of hope here, even though obviously we do better without any face coverings, and the children could still largely interpret the emotions that were being conveyed.
What do you reckon to the variation in how good the kids were at picking up on the different emotions?
It's to be expected. So we know that fear and surprise are really difficult to distinguish in terms of the real main key emotions. Often anger and sadness are mixed up. So I thought it was really interesting that the children could clearly distinguish between sadness and anger. We're talking about still images of faces here. Now, in the street, if you met somebody and they were sad or angry, there's many more cues that you would rely on aside from their face. So their body language, what they're saying or shouting, that type of thing, you can clearly distinguish. But just looking at those images, it can be really tricky to distinguish between sadness and anger. And it's really a nice finding to see that the children could still make out those emotions.
How diverse were the group of kids? I'm just wondering if this kind of thing varies by individual or maybe by background or culture.
So there was a really nice spread of children. Oftentimes, in this type of research, there can be a tendency to focus on one subgroup, the majority subgroup of children. But this one had a really nice balance across different ethnicities in the children, and a fairly good gender balance between the children. There wasn't any massively major findings there, other than boys were slightly quicker at recognizing the anger emotion than girls were.
The people, the faces, these were strangers, right? Just pictures on a screen.
They were all strangers, yes, taken from a database that is really commonly used, that where we have really established, these are all sad faces, and people have validated these as looking like sad
Hmm.
faces or angry faces and so forth.
Do you suspect this might change in any way depending on the relationship to the adult? Say it's your parent or your teacher, you know, those really key interactions.
That's a really good point. So, yes, we will definitely get better if it's a familiar face, just simply because we're much more familiar with how those faces look under different conditions. And we can assimilate that idea of someone's face in lots of different conditions into a nice template of their face. And it's really easy for us to use very few cues then with the people we're familiar with to infer that emotion. But in reality, the people that these children are going to see with face masks aren't predominantly going to be their parents or their
Mm.
teachers. Predominantly, it's going to be strangers on the street.
What about kids who might find emotional communication difficult anyway? Say maybe kids who are autistic.
That's a good question, because autistic children and autistic adults don't have as strong a tendency as people who aren't autistic. They don't have that strong tendency to look to the eyes and focus and linger on the eye area. So there is some evidence to suggest that people who are autistic prefer to look at featural cues such as the mouth area to get their emotional cues. So there hasn't been a lot of research done on this in terms of face mask wearing or usage, but we would expect, yes, that to be further impaired if your preference is not to look at the eye area but to use the mouth for your cues for emotions. Yes, we would expect that to be a more significant impairment.
Like you said earlier, obviously emotions are quite nuanced. You know, there's facial expression, there's body language taken into account. How significant do you think this study is overall?
I think it's not massively significant in terms of whether, children can ever interpret emotion in the world or their social development. I think really what it does is placate some of the worry that is really rampant at the moment, that all parents are so worried about their children's social development. And it's nice to have a really small piece of comfort that says, look, well, one thing you don't need to worry about is, oh my goodness, my children aren't getting enough input of facial emotion and they're going to be stunted for life. So that it's a nice, very small but meaningful reassurance for parents who are already quite worried.
So we know that the kids are better than chance in this laboratory environment, which is quite well controlled with this standard face stimuli. I was wondering whether we think that will play out in the real world, which is kind of busy and lots going on. Would that better than chance performance be enough for children to reliably recognize emotions out in the real world?
I think that's a really good question. And if we wanted to make this more realistic, we would, of course, be introducing lots more useful social cues as well as lots more busyness in the visual environment. So, yes, whereas we don't know in the real world if children would still be able to recognize these emotions through masks, they would have far much more information in terms of somebody's body language and what they were conveying in other ways apart from their facial expressions. So it'd be very difficult to tease those two apart, which is it's why it's quite nice to have this in isolation telling us just about the interpretation of facial emotion.
Helen Keyes there, as well as Duncan Nastle. And that paper was published in the journal PLOS One. Now, Duncan this month looked at a review which explored how many teachers believed in the concept of learning styles, how likely they were to implement them in the classroom, whether this belief is reducing or not over time, and whether intervening to counter this belief works.
Learning styles is the concept that each person has a subtly different way of learning. So some people might prefer information to come in a kind of visual format. Some may be in an auditory format. Some might prefer to learn by doing something themselves, a so-called kinesthetic learner. And the idea is that if you can match someone's learning style to the way you deliver information in the classroom, then you'll create the optimal environment for them to learn, and you will boost their learning over time.
What evidence is there to support this idea about how people learn?
Oh, I'm afraid there isn't very much evidence. In fact, the data show that certainly kids will tell you that they have a preferred style. They'll be only too quick to tell you what their preferred style is. However, the data shows that they are no better in their preferred style than in any other. So, of course, everyone's got a preference, but that doesn't seem to correspond at all to learning. And actually, there can be some dangers of promoting the idea of learning styles. Because, for example, if I tell you that you're a kinesthetic learner, when I try and deliver something in class in a kind of auditory or visual format, what's the point in you paying attention? After all, this isn't in your preferred style. So the evidence that it works is null. There isn't any. And actually, there's increasing realization that there can be some negative consequences of promoting this idea.
So, if there isn't any evidence that it works, then where did the idea come from?
Well, the original idea comes from a kind of management consultancy. But the reason that it got into teaching is because, as we'll kind of come to later on, it still features in teacher training and has still been featured in a number, even quite recent teacher training textbooks. And that's how it's gotten into the classroom.
What did the review find then?
Well, what they wanted to establish is whether or not teachers still believe in learning styles. And the way that they went about doing that was to do a systematic review. So they have very careful criteria for choosing different published studies. And that resulted in 33 different studies covering the views of over 15,000 teachers surveyed between 2009 and 2020, so over a 10-year span. And of those teachers, over 89% believe in learning styles, that if you match learning style with the delivery, you'll improve their learning. And pretty much all of those who believe in it intend to use it in their classroom practice.
What did the review find in terms of the trends of are more or less people believing this?
Well, it's certainly not getting any better. So what you might expect to see is if fewer and fewer people are believing in learning styles, then as time progresses, say from 2009 through to 2020, gradually fewer teachers will say they believe it. But that's not true. There's no significant relationship with time. And actually, if you split it out between trainee teachers and established teachers, actually the trainee teachers are slightly more likely to believe in learning styles, even though those are the more recent graduates of teacher training. So there isn't any evidence that's getting better in time. It seems to suggest that basically it's pretty constant over this 10-year period.
If there is no evidence that this works, does the act of communicating that make a difference?
It does. So there's only 4 studies that have tried to intervene, but they do all show that it's pretty effective. So if you deliver some kind of campaign to explain to teachers that this is nonsense, then their belief in it goes from about 78% down to 37%. So you can really change perspectives. I mean, I wonder what's happening in those 37% who presumably just don't believe the intervention. But it does show that it's pretty effective.
What does science tell us about the best ways to learn? Is a variety in learning and teaching methods useful?
Yes, but not for the reasons that learning styles says it should be. So we know that if you deliver information from multiple different perspectives, then you get what's called deep processing. So the reason that it's good to learn information from lots of different perspectives is because you lay down more durable long-term memories associated with that, rather than a more kind of shallow trace.
By different perspectives, are you talking about reading something versus listening to a teacher versus doing something?
Yeah, exactly. And the idea is because each time you re-encounter the information in a different format, you kind of reconstruct the traces from the first time. And with each reconstruction, you make the decay slope of the memory more shallow. And thus it becomes more and more durable with time. But that's not because you're pigeonholing kids into learning in one way or another. It's just a general principle that the more variety in the way information is delivered tends to produce more durable memories.
Oh, I see. So even if I prefer learning via someone talking to me, actually doing all of those things is probably good for my learning. Is that what you're saying?
Yeah, exactly. And you also create what's called context independent memory. There's a really strong effect, which is that, let's say you learn stuff in one format in one room, you're more likely to remember it when you have to be in that room using the same format. Whereas if you have variety in the style and locations of presentation, then you tend to get memories that are more durable across different contexts and across different formats.
What did the review make of the actual quality of the evidence they were looking at?
Big caveats. It's really hard to get a really unbiased measure of sort of people's beliefs in something using an opportunity sample, which the vast majority of these studies are. And that's because the people who engage in that kind of thing might not be your typical teacher. And almost always, these questions about learning styles and beliefs in learning styles are embedded alongside lots of other neuromyth questions and things that might seem much less plausible. And so there could be a biasing effect in that when they come across the learning styles questions, they think, well, that seems much more plausible than the nonsense I've just read. And so all of these factors will really influence how true a measure of belief in learning styles you're actually able to get.
Okay, so overall, what do you think we can draw then from this review about the state of belief in learning styles?
I've been talking about learning styles in schools for about 10 years. And I would say that's still the case that most times I mention it, people believe it. So I would say the figure of sort of 80 to 90%. It's probably a little bit high for the UK, but it's not far off. The reason behind that is because, well, there's a law called Brandolini's law, which I will not quote verbatim, but it's the idea that the energy required to refute nonsense is an order of magnitude bigger than that needed to create it. If you look, for example, at the first big study showing that learning styles has a big effect, that's been cited more than 600 times. And 2 years later, another study came out demonstrating the original study was nonsense and there is no effect at all. That second study's only been cited 60 times. When you get an idea out there, it gains traction very easily, and to put the genie back in the bottle takes an awful lot more energy.
Duncan Astell from Cambridge University, and the study was published in the journal Frontiers in Education. As usual, if you'd like to follow up on the references to these papers, the links are on this episode's show page, nakedscientist.com/neuroscience. If you click on the interview for this section and scroll down, the references are listed below the interview transcript. If you've got thoughts, feedback, questions, or there's something you'd like us to discuss, get in touch. You can email neuroscience@nakedscientists.com.
Identical twins are supposed to be identical, right?
On average, you will find about 5 mutations of this sort that differ.
Is that a problem for the many geneticists who use twins in their studies?
What I'm afraid people will take away from it is the idea, well, the twin method's no good because identical twins have differences.
Find out on January's edition of Naked Genetics, wherever you get your podcasts.
Music in the programme is sponsored by Epidemic Sound, perfect music for audio and video productions. Now, for the rest of the show, we're taking a look at hallucinations. Hallucinations involve experiencing something that doesn't exist in the external environment. It's a complex topic, and one that I can't really do justice to in 20 minutes or so. We'll be delving into just some of the science surrounding these phenomena, finding out what is understood about what's happening in the brain during a hallucination, considering visual hallucinations in blind people, and pondering the mysterious nature of sleep paralysis. If you're experiencing hallucinations, the UK National Health Service website recommends that you make contact with your doctor, and there's a link to the nhs.uk page discussing this on this episode's show page at nakedscientist.com. First up, let's consider the basics. Colleen Rowlands is a fourth-year psychiatry PhD student at Cambridge University who looks at how the structure and function of the brain supports the experience of hallucinations.
Hallucinations are a sensory experience, often with a compelling sense of reality, that occurs in the absence of a corresponding stimulus in the physical world. So, for instance, hearing someone speak to you when there's in fact no one there, or seeing a person or an animal run across your visual scene when that wasn't actually caused by anything. It can also occur in other sensory modalities, such as smelling or tasting things that aren't there, or even feeling someone touch you.
Wow, you can have a smell hallucination? Really?
Yeah, I've heard someone tell me that they smell death, which sounds quite distressing.
What are they like?
It often depends on the condition that they can occur in. So for people with a diagnosis of schizophrenia, we know that these hallucinations are more often auditory. They usually manifest as hearing voices, which often say quite nasty or critical things. Whereas for in older age, in people with Parkinson's or Lewy body dementia, they're often more visual. People may see either figures or animals that don't seem to acknowledge them. But there's also a lot of variation within that, so different people can have different experiences.
Are hallucinations always tied into a health problem?
No, they're definitely not. And there's actually increasing recognition that these experiences can occur on a spectrum from health to illness, and people without a clinical diagnosis can experience them too. They can also occur in situations that involve stress, isolation, or bereavement. But they can also occur for seemingly no rhyme or reason, and may also sort of either be neutral experiences or even contribute to meaningful experiences.
I want to ask you why they occur, and I've got the sense that this might be quite a big question. Could you perhaps categorize hallucinations for us in any way? How do scientists like you tend to think about them?
Historically, they've been classified more by clinical diagnosis. So we might talk about hallucinations in schizophrenia, which is more what I focus on, compared to those as a cause of Charles Bonnet syndrome, for instance. But as I mentioned before, there's increasing recognition and also research that these occur in people without a psychiatric diagnosis as well, or without any clinical history. So there's increasing efforts to understand the variety of hallucinations and maybe have a better classification system for them.
So does the mechanism behind the hallucination depend on why you're having it? Say, would how a schizophrenic hallucination works, would that be different to if you're hallucinating because you're incredibly tired? Or are there any sort of fundamental mechanisms that you can talk about?
Bit of a basic explanation. Hallucinations are thought to emerge from different connectivity or different communication between brain regions. So we think that hallucinations certainly involve sensory regions, so auditory or visual regions for auditory or visual hallucinations. And these seem to interact or speak to higher order prefrontal areas of the brain that are involved more with monitoring where the sensory information is coming from, whether it's internal or external. There are likely different mechanisms that support these varieties of hallucinations, but we think there are also commonalities between them as well. So from the perspective of brain science, which is what I research, we can think of as hallucinations as manifesting from differences in patterns of brain connectivity between different brain regions or networks. And some of these brain regions or networks might be the same, that would give cause to different hallucinations, and others might be very different.
As you said, you study schizophrenia and hallucinations associated with schizophrenia. Before I ask you a bit more about your research, what actually is schizophrenia?
That is a very good question that I'm sure many clinicians might have trouble giving you a clear answer to. It's a psychiatric illness that often involves symptoms that sort of dissociate from reality, so hallucinations or delusions or disorganized perceptions or thoughts. There's a lot of variety in how it presents in different people, and so this certainly poses different challenges to researching it and also treating it. My interest comes in the specific symptom of hallucinations that around 60 to 80% of people with a diagnosis of schizophrenia will experience.
How exactly are you studying this?
I use some cognitive research about the psychology or mental processes, some qualitative research about the lived experience, but mainly I use neuroimaging, so magnetic resonance imaging, or functional MRI, to study how the structure and function of the brain supports hallucinations.
So, what are you looking for? Do you know which bits of the brain probably are active in a hallucination?
It likely involves both sensory areas of the brain. So, for auditory hallucinations, that likely involves brain regions or networks that process hearing and language. It also seems to involve medial prefrontal bits of the brain, so that is towards the front and middle of the brain. And these regions are involved more in self-monitoring or directing attention to salient stimuli.
What exactly is the question you're trying to answer?
So I'm really interested in how the different ways that the brain is folded can contribute to these experiences. Research by myself and others have shown that differences in brain folding patterns are actually associated with whether people with schizophrenia will experience hallucinations. And this is really interesting because the way the brain folds is developed in utero in the second or third trimester of pregnancy. So it's suggesting that something during brain development might scaffold the way people experience the world and influence whether or not they'll have these unusual sensory experiences.
Hallucinations can be very varied in their modality, in their content, in their emotional content, in why they're occurring in the first place. Where does the research need to go in terms of better understanding this phenomenon, do you reckon?
A helpful direction, and also where it does seem to be going, is better understanding these varieties of experiences. So, like you said, the variety of conditions that can cause hallucinations. Probably more research about what they're actually like. A lot of our clinical assessments simply involve sort of, do you hear or see things that aren't there? But that says nothing about the content of what they're like. That says nothing about sort of the emotions that that's associated with or how it impacts the daily life. I think more research about what the experiences are like, as well as the different ways and the different risk factors that can produce these hallucinations. I've spoken a lot about the biology of hallucinations and the brain science, but of course there are many different levels of explanation that you can speak to them about. And we know that stress, trauma, or intense negative emotions can be risk factors for hallucinations as well.
Colleen Rowlands. Now, Colleen mentioned in passing a syndrome called Charles-Bonnet, which causes a person whose vision has started to deteriorate to see things that aren't real, i.e. hallucinate, as a result. These hallucinations can be quite worrying. And a paper published in the journal Brain recently, looking at these hallucinations in 5 Charles-Bonnet patients, suggests that a build-up in background brain activity, so-called spontaneous activity, could give rise to these hallucinations.
Basically, our brains need to remain active. It's just to keep cells going. There is this random noise in our system that just keeps our brains going.
And by noise in this sense, we're talking electrical activity firing between neurons. Is that right?
Exactly.
That's Avital Khachami from UCL, one of the authors on the paper. Avital and her colleagues wanted to understand the role of this spontaneous brain activity that isn't related to the environment. Could it cause individuals to behave, i.e. hallucinate, spontaneously?
We have found that in blind people who experience visual hallucinations, it is what we call the Charles-Bonnet syndrome, the visual areas of the brain are working healthily, just like in any other brain of a sighted individual. And this healthy and normal activity gives rise to visual hallucinations. These brain areas are not activated by some external image that they see because these individuals are blind. Instead, they're activated by spontaneous brain activity. And this internal activity causes hallucinations.
So why are you looking at this in people who can't see but are hallucinating?
The problem is, if I ask you to behave spontaneously, I'm pretty sure you won't be able to do so because the mere instruction is a spontaneity killer. So spontaneous behavior has to be something that is induced by you, by some internal desire you have. The second reason is that when you behave, some signals in your brain would be evoked by the actual behavior and by the environment. And we can't separate those from the spontaneous brain activity. However, in blind individuals, the visual centers in the brain don't respond to the environment. So what happens in their visual centers is just spontaneous activations. On the other hand, they experience vision, and this vision is completely spontaneous, is completely uncontrolled. They cannot control the content or the onset of these hallucinations. So this is why we chose these individuals to study whether spontaneous brain activity could underlie spontaneous behavior.
What experiments did you do?
We asked these participants to report whenever they experience hallucinations in the fMRI scanner, which allows us to look at their brain activity non-invasively. And we recorded what they say when they see hallucinations. And after being scanned, we played back these recordings to them and asked them to give as many details as they can about the content of their hallucinations. So, for example, there's one participant who hallucinates a face. It's a face she has never seen before when she was able to see. But she repeatedly hallucinates this face. She can describe it in many details. Another participant sees something that he describes as a kaleidoscope, just rapidly altering shapes and colors all across his visual field.
Is it quite important for this experiment that these people have had sight previously?
It is very important because when a participant says, "I see a face," then I can understand what she means. She has seen many faces before. Now, a person who was never sighted before, what we call congenitally blind, if he says he sees a face, then I can't really know what he means by that.
Okay, so you've got in this case, 5 participants, right, in this group, and you've put
Yes.
them in an fMRI scanner, so you understand which bits of the brain are active during these hallucinations, and you've got quite a detailed account of these hallucinations. What do you do next?
So now, if you think about it, I have a scenario. I know which images appear and when. And based on these scenarios, I can build a movie describing the hallucinations. And I take these movies that are made by recording actors or taking images, and I show these movies to sighted individuals while I scan their brains in the fMRI scanner. And I ask them to report what they see, just like the blind individuals did.
You're trying to get it as close as possible that they're having the same experience, right?
Exactly. So now I have 2 groups of participants who experience a very similar stream of events, of visual events, but one group is blind and the other one is sighted. And I want to understand what's different in the way their brain is activated in this experience. Another difference is that in the Charles Bonnet syndrome group, they're seeing internal content, while the sighted controls are seeing a content that we show them. So we introduced another condition in which we see internal content, but it is not spontaneous. We asked blind individuals who do not hallucinate to imagine. We tell them when to imagine, and they do it. So what they see is not out there in the environment, it's internal, but it is not spontaneous.
So you've got these 3 versions of vision, as it were. They're all seeing the same thing, or as close as possible, and then you've looked at what their brains are doing. What did you find?
The first thing we found was that across these 3 groups and conditions, the same brain areas are working, the same brain areas that are used in all our brains in order to see. This is what we call the visual system. However, the timing in which the visual system is activated is different. In all these cases of non-spontaneous vision, in the sighted controls who see our movies and in the blind controls who are engaged in imagery, first the instruction is given or the image is shown, and only then the brain reacts to it and we see activation in the visual system. However, in those individuals with Charles Bonnet syndrome who hallucinate, first the visual system is activated, and once we see enough activation, once it reaches enough amplitude, only then the participants report to hallucinate.
You did only have 5 people in that group, so is that enough to say something meaningful? What can you say from this?
It is true our sample is very small. So, for example, we can't say anything based on 5 participants about the entire population of people suffering from Charles-Bonnet syndrome. We can't say that visual hallucinations are always the result of spontaneous brain activity in the brain. We can say that in those individuals, this is the case. So, although there could be other brain mechanisms that give rise to visual hallucinations in the blind, we can identify one of them in our subgroup of participants. We can also use this example as a test case. In these 5 individuals, we can say that spontaneous brain activity can evoke behavior. So it is indeed possible that spontaneous brain activity could induce behavior in typical individuals who see.
What would you say these findings, albeit in 5 people, might mean for someone who's got Charles-Bonnet syndrome?
These individuals know they are blind and they know it doesn't make sense that they see. And for this reason, some of them are afraid of being tagged as insane. So they wouldn't necessarily tell their family members or their doctors, and it causes a lot of stress. What we found is that the reason they can see is that their visual system is intact. It is not deteriorated. It is not processing other information. It is intact. It does what it knows to do in a sighted brain. It knows to take signals and to interpret them as vision.
These slow waves, they're not just something that happen in blind people, right? Sighted people, everyone experiences these as far as I'm aware. So does that mean the same visual hallucinations could be happening in someone who is sighted if they've got their eyes shut?
That's a very interesting question. So, first of all, yes, we believe that whenever we close our eyes and go to sleep, for example, then we all experience visual hallucinations. We experience dreams. And it could very well be that these spontaneous fluctuations in our brains could trigger visual experiences that are dreams.
And Avital added, this doesn't just stop with the visual system. She explained there's spontaneous activity in areas like the motor system too. Avital Chachami from UCL. But let's stick with the subject of dreams, or nightmares to be precise, because the final interview today concerns sleep paralysis. And Cambridge University neuroscientist Baland Jalal is very interested in this phenomenon.
Imagine lying in your bed, sleeping, but then realizing that you're actually awake, but you can't move or you can't speak. Suddenly you feel like, oh, there might be some ominous, ghostly presence in the room. Before you know it, this evil thing is on your chest, choking you, suffocating you. Your limbs are being held down, and perhaps you might even see this ghostly figure in front of you. This could be a classic scenario of sleep paralysis, so quite frightening.
Sleep paralysis occurs at the intersection of being awake and asleep. It's not always, though it is mostly, a negative experience, and the phenomenon isn't fully understood. Baland reckons about 20% of people may have had at least one experience of sleep paralysis of some kind.
This window, this borderland situation where you find yourself between REM and wakefulness. In fact, when we do EEG studies or whatever, we find that it's really a strange state that has elements of wakefulness and elements of REM sleep colliding, right? You have REM physiology paralyzing you and being active, while your wakefulness centers are slowly becoming more active. You have rapid breathing, pulse rate is elevated. As you said, you have these vivid and crisp dreams during REM. And so when you go in and out of REM, that's where you have a lot of interesting things, going on.
For one, he says, the structures responsible for your sense of self, the temporoparietal junction, take a nap during REM sleep, which, he said, explains why sometimes when you're dreaming, you might actually be looking at yourself, like you're watching yourself in a documentary, rather than feeling like you are yourself in the first person. Another bit of the brain, he told me, that is less active during REM sleep is the dorsal lateral prefrontal cortex, important for us creating a logical, sensible, cohesive world. So your sense of perception can go awry.
So you might find yourself on the moon, opening a fridge, taking snacks, but then suddenly you're in Buckingham Palace having tea with the Queen, and everything is just messed up: time, space, people. REM sleep has all these interesting signatures, which really play into then how things like sleep paralysis is experienced, because it's very much a REM sleep phenomenon.
So, what then is going on in an episode of sleep paralysis? Balan told me that the paralysis is a defense mechanism against potentially hurting yourself or a sleeping partner by moving around when you're asleep. But sleep paralysis is a system glitch, essentially. You're in REM sleep, and therefore paralysed, while the outer layers of your brain are waking up. He theorises that, a bit like with phantom limb sensations, your body is sending the move commands that are instinctual with being awake, but as you're paralysed, there's no feedback coming from your limbs to your brain.
When you just keep sending those signals, move, move, lacking this proprioceptive feedback, then that will feel like something is holding you down, or they will feel like it's pain or spasm, which is interpreted as somebody is or something is holding you down. The same with breathing. When you try to control your breathing manually and it's automatically breathing, you can't. It will feel like a pressure or suffocation sensations.
And Balan reckons there may be a similar explanation for the ghostly presences that some people experience.
It has to do, we believe, with our sense of self being distorted. So we talked about a little bit on sort of how the sense of self is scaffolded and created in certain structures in the brain, in the what we call the parietal lobes. When we disrupt these regions using, say, an electrical current, you might feel like a ghostly other person is mimicking your postures. These structures are involved in this. A theory that we proposed is that during sleep paralysis, you're sending all these commands from your motor cortex responsible for movement saying move. And since there's no feedback coming back from your limbs, your body telling your brain how to create a body image, your sense of self gets distorted. And so what we believe it does then, it sort of fills in the blank for you, like Google autocorrect projects your body image out there in space. We call this an out-of-body experience. More typically, you see this intruder-like creature. And this could just be understood as a different type of hallucination where you create a scenario of fear around that projected self being out there in space. And so you create a story around this. And so when you have fear, when you have anxiety, emotional parts of the brain that are responsible for fear being hyperactive, your brain creates a story around that. And that would typically, entail a ghostly creature in your room, and so we actually believe it's at your own projected body image. So that is one theory.
Is having sleep paralysis necessarily an indication that something is wrong?
No, not at all. So a lot of people have these from time to time without having a mental condition or psychiatric condition per se. So it's not dangerous in that way. It tends to be more when you have frequently occurring fearful sleep paralysis. So when it repeats itself and becomes a chronic phenomenon, and that would potentially be a reason for concern slightly in terms of your well-being.
What can actually be done then to help people who are suffering with sleep paralysis? Besides the usual sleep hygiene stuff you might expect and getting help with any underlying conditions that might be triggering it, the UK National Health Service website mentions cognitive behavioural therapy and low-dose antidepressants. Baland has recently published a pilot study about a psychological sleep paralysis treatment that he's come up with called meditation relaxation therapy. Step 1, he says, is to get rid of the panic.
You tell yourself, this is not a demonic figure or whatever. This is common all around the world. It's benign, it's temporary, and finding ways to reappraise or reinterpret the dangers of it.
Step 2, try to emotionally and psychologically distance yourself from the experience. Step 3, direct all your attention to something positive.
Since you have limited attention, and we know this from neuroscience, you might as well, hijack the system to your own benefit and focus all your attention on something extremely positive and center all your emotions on this object in order for you to, in effect, take control and be in charge of what's going on. This is a way to divert your attention away from potential hallucinations.
And step 4, don't try to take control over your movement.
This goes back to some of the theories that we've proposed in terms of when you try to act out your movement, you will feel like there's a spasm and there's pain in your limbs. And these are then could go into the interpretation of a ghostly figure and whatnot.
It sounds deceptively simple, but anyone knows who's been in a panic that trying to think logically when you're panicking is incredibly difficult. Balan's done a pilot study of this approach with 10 people suffering from narcolepsy.
And there we found that applying this treatment did improve sleep paralysis by around actually 50%. So this was 8 weeks of applying this. So it was a big effect. But obviously, we have to be cautious in interpreting these findings. So this was an extremely small study. Basically, it's a study that would then give us a rationale for going into bigger studies, but we can't infer that it's effective. Right now, we're actually running a larger study. So this is not narcoleptics, but people in the general population that have frequently occurring sleep paralysis. So a large study with a placebo condition, see if it works.
Balan Jalal there from Cambridge University, and it'll be interesting to see how his proposed treatment progresses. That's it for our journey through the science of hallucinations, and actually we've come to the end of the show. Thank you so much to all of our guests. You've heard from Colleen Rollins, Avital Khachami, Balan Jalal, as well as Duncan Astell and Helen Keyes. Join us next time for more Naked Neuroscience. Until then, thank you very much for listening, look after yourselves, and goodbye.